Okay, class. So I think only 10 of you. So I think should be around 20. I think only around less than 50% of the attendance, I hope the others can watch the video. Okay, class. Okay, let's continue with our lessons today. Today we're going to finish off the electric field. Then we're going to continue with another topic if we have time. Okay, but first let me go through the electric field first. I have finished up only the last part. Everyone can hear me, right?
Yeah.
Okay, so let me go back to the slide. Okay, so you can see my screen. Okay. So far we learned about electric field is what? Let me go to the whiteboard first. So what you learned about electric field so far? First, you learned about Coulomb's law. What Coulomb's law said? F equals to 1 over
Q.
Yeah, Q over R squared. Or you can write K Q over R squared. Okay, so yeah. So Coulomb's law. Then after that, you learn about electric field strength. Electric field strength. What over what is electric field strength? Your AS knowledge, force per unit, positive, test charge, and this is your force divided by the test charge. You end up getting what formula? KQ over R squared. The charge which still survive in the formula is the center charge. But if you use force per unit test charge, then this is going to be a test charge. Don't get confused with the test charge and the center charge. If you use KQ R squared to find the E, it must be the center charge. If you want to find electric field strength by using force F over Q, that charge, the Q down there is a test charge. Test charge who experienced the force. Okay, then we learn about what? Electric potential. What is electric potential? What over what? Work done per unit, positive, test charge. To bring where? From infinity to that point. Okay. So then what is the formula you found? KQ over R. KQ over R. So this is the three formulas you learn. First one, second one, and the third one. Okay, force. What is the unit? Newton. Of course, we know. Vector or scalar? It's a vector quantity. It's a vector quantity. Electric field strength. What is the unit? Force per unit charge. So Newton per coulomb. Vector or scalar? Electric field strength. Also vector as a direction. Electric potential is what? What is the unit for electric potential? Work done per unit charge should be joule per coulomb. Vector or scalar? It's a scalar quantity. It's a scalar quantity. Okay, next, the fourth one, electric potential energy. How do you find? The Q times with changes in potential is your electric potential energy. Okay, so what do you get the formula? K Q over R, the fourth one. What is the unit? Joule. Also scalar. It's also scalar. Okay. Okay, yeah. So yeah, these are the four things you learn. Okay. So two scalar, two vector. Okay. So remember these four equations. These four equations is important. Designed only for what? Non-uniform charge, point charge. Okay. Okay. Today, what we're going to learn is this one. Okay. Relation between relation between V and E. Okay. Relation between V and E. Okay. What is V? Electric potential and electric field strength. They have some sort of relation. We found that electric field strength is a vector quantity. Electric potential, we found it's a scalar quantity. Electric potential is joule and electric field strength is Newton per coulomb. They have some sort of relation. Okay, the relation is the one derived here. Okay, you see this picture. Consider a positive test charge Q, small q, placed near a positive point charge Q, capital Q, a small q placed close to the capital Q, and the small q was moved towards the capital Q. Okay, the work done by you is what? The work done by you, by your force, the force is applied, okay? Yeah. The force, actually the positive charge pushes the force with F, okay? The force towards this direction, with the same direction in R, we put negative F lah. So work done is negative FR. Negative shows the force by the force by the field lah, by the field. Actually, the force by the field is F outside, but here we put negative F lah. The work done by the field. Work done by the field is negative FR. Work done by you is FR. FR, positive FR lah. If you have a 2 positive charge, okay, you want to get closer, you did a positive work, okay, but the field does a negative work when get closer, okay, so that's why it's negative, negative. So negative lah. The negative sign indicates that the electric field is increasing in the opposite direction lah. Okay, from this formula, work done is F changes of R, okay, and some sort of rearrangement. You don't need to know this derivation. Okay, the F they replace with both sides they divide with the test charge Q. Mathematically, you can divide or times or plus in both sides of an equation. Is not mathematically correct. So here they divide with the test charge just to bring F over Q, because F over Q can change to E, electric field strength. Then they found that W over Q is found to be the electric potential. So electric potential and electric field strength is formed. And when we shift the changes to R, this is the final formula. Okay, this is the relation between electric field strength and electric potential. E is related to electric potential as this. dVdr is known as a potential gradient. Okay, so electric field strength is negative of the potential gradient. Electric field strength is what? Is negative of the potential gradient. Okay, you can visualize this as your acceleration. You know, acceleration is dv dt, right? dv dt. You see, acceleration is rate of changes of velocity, dv dt. Like gradient of the vt graph, and if you plot what? If you plot vt graph, the gradient is, we know, is the acceleration, right? Same thing here. For electric field strength, if you have a V versus R graph, the negative of the gradient is your electric field strength. What is that? The negative of the gradient. You get the gradient, but you put a negative, make it negative, then that's the electric field strength. Okay, so electric field strength is negative of potential gradient. The last relation you're going to learn under electric field strength. Under electric field. Okay, what I'm trying to say here is, maybe you can understand better the next slide. Okay, go to the next slide. You see the next slide. So here you see. What is the relation you learn? This is the relation you learn. Electric field strength is negative of the potential gradient. Okay, you see, let's say you have a positive charge. You have a positive charge here. Okay, a positive charge. What is the potential at infinite will be? Anyone? Will be 0, right? Will be 0. When get closer, the potential get more positive, right? Electric potential. What is the electric potential formula? KQ over R, right? KQ over R. So if you plot V versus R, V versus R distance, is because you see V and R, they are inversely proportional. So you get a curve. You will get a curve. So let's say you have a positive charge. The potential from infinite 0 increases. Okay, at this particular point, let's say at this point, it's a point A. At this point, I want you to find what is electric field strength at point A. What is the electric field strength at point A? Okay, the electric field strength at point A is equivalent to what? Electric field strength at point A is equivalent to negative of the potential gradient. The negative of the potential gradient, the negative of the gradient. So you see here at this graph. So let's say I want electric field strength at 8. I want E. Let's say the A is 8 lah. 8. A is actually 8 from the center. From the center of the charge to the point here is 8. Let's say 8 meter. Let's say the unit here 8 meter. So 8 meter. So 8 meter. I want to find the electric field strength. So at this graph, how do you find electric field strength? At this point, find the gradient. Draw a tangent, find the gradient. Okay, let's say the gradient you get here, let's say the gradient you get here, negative 10. Then what is the electric field strength? Electric field strength is negative of the potential gradient, negative of the potential gradient. So negative of the gradient is what? Negative 10. So the electric field strength at that point is 10. So that's 10. Okay. So from the potential V versus R graph, you find the gradient at every point. If you want to know electric field here at this point, just find the gradient dV dr. Okay. The negative, then that's your electric field strength. Okay. So remember, if they give V versus R graph, you can find electric field strength, just negative of the potential gradient. Like last time, if they give you VT graph, there is a graph like this. They're asking what is the acceleration at this point. What you will do? You will try to do a tangent. You find the gradient. Then the gradient is your acceleration one. The same concept here. You want to know electric field strength from potential versus R graph. Just find the gradient, but you have to do something different than the acceleration. The extra you have to do is negative of the gradient. Is your electric field strength. Okay. So any questions so far? Okay. Because a new idea, maybe we can do questions, maybe you can understand. Okay, one example, next slide. Okay, you see one example here. This is V versus R. V versus R. Okay, it's positive, it's curving down. Okay, we assume it's a positive charge at the center, curving down. So they're asking, the graph shows a variation potential difference of from a charge dome of a Van de Graaff generator. Okay, use the graph together with the E negative dVdr to find the electric field strength. At which point? At 0.3 meter. At 0.3 meter, what is the electric field strength? So in exam, if they ask like this, what you should do? This is a V versus R graph. This is a V versus R graph. So what do you have to do? At 0.3, at this point, you must find what? You must find the gradient. Draw the tangent. Draw the tangent. Find the gradient. The changes of V over changes of R. So find the gradient. Gradient is changes of V over changes of R. Then, the tangent. Then electric field strength going to be what? Negative of this value, whatever value you get, is your electric field strength. So according to here, the field strength will be the negative of the gradient at 0.3. This should be the value of 1.7 times 10 to the power 5. So you give a positive answer. Because the gradient itself looks like negative. The gradient itself looks like negative. So negative become positive answer finally. Okay. Any questions? Okay. Okay, let me clear this. I want to add more questions here. Okay. Plus, this is V versus R. V versus R. Tell me, point A, point B, point C. Point A is here, point B is at the center, point C is at the bottom. Tell me, electric field at A, electric field at B, electric field at C. At which point the electric field is the strongest? A, B, or C? EA greater or EB greater? Anyone from this graph? EA is greater. EA is greater than EB. If they ask for reason why, what are you going to say from this graph? You see, electric field strength is actually equal to the negative of the potential gradient. You must mention this. Then you see, because gradient, the magnitude of the gradient at the beginning is greatest, therefore EA is greater than EB. So you must mention this relation. Electric field strength is negative of the potential gradient. Okay. Okay. So before we go to this, I need to go to the whiteboard to strengthen this idea. Okay. So I clear this. Okay. Plus you see here. So now in exam, they will give you V versus R graph. They will ask you to plot sketch E versus R. Okay, they can ask you to sketch here or from here anyway. Like last time, VT graph is given. They ask you to draw the AT graph. Like that, same idea. But the quantity now is a potential with electric field strength. Okay. Okay. So let's see here. How do you do this? So what is the relation? E is negative of the potential gradient. Potential gradient. Okay, let's say I give a graph V graph like this. V graph is like this, a straight line. How's the E versus R graph should look like? Anyone? So how do you see this relation? If you difficult for you to view the electric field strength and the gravitational, electric potential, you can view as I told you, like acceleration and velocity. Okay, just to be simplified, take the electric potential, assume like velocity, and the electric field strength assume like acceleration. The only difference is this is negative. Okay, let's say this is imagine like a velocity graph. Okay, like a velocity graph. How's the acceleration graph looks like?
Horizontal.
Straight line.
Horizontal, but positive or negative? Positive, right?
Positive.
It will be positive lah. It will be positive. But now you treat with negative lah, because it has a negative. Therefore, what do you do? Reflection at x-axis. So the graph will be here. Okay, it won't be here. So the extra thing you have to do by comparing B to A, velocity with acceleration is you assume potential as velocity graph, you draw the E graph, acceleration graph. Then to convert to electric field strength, you just, whatever graph you've drawn, you just do a reflection at x-axis. And that's your electric field strength graph. Okay? Good idea. Okay. So let's go another one. Try to sketch for me how the graph looks like. V versus R was like this. It's a V shape like this, going down, going up. Okay, this is R1. Okay, so how's your E versus R graph? Electric field strength is negative of the potential gradient. So get some idea how do you draw? Draw part by part now. Draw the first one, then draw the second one. Okay, so E is negative of the potential gradient. You assume the potential like what? The potential you imagine is like the velocity. Imagine like the velocity. And the E you assume like acceleration, but you must do a negative later. You have to reflect x-axis. Okay, so if it's a velocity graph, first is the velocity graph. How's the acceleration graph looks like? The velocity graph, negative gradient. So acceleration going to be negative, right? Negative flat line. Yeah, correct. And then 2 will immediately go up. Positive. This is the first and the second. We're just drawing an acceleration graph now. This is acceleration graph. But you want to convert to electric field strength, you must reflect it on the x-axis. So the graph finally going to change what? It's going to change the other way around. So the final graph, of course, going to be like this, like this. Okay, yeah. So the final graph is, of course, this one. After your reflection. So the graph going to take up like constant, like this, positive and negative. So this is the electric field strength graph. Okay. So learn how to sketch potential to electric field strength. Imagine like velocity to acceleration, but do a negative. Reflect it at x-axis to find electric field strength graph. Okay. Okay. If you don't have question, I go for another one now. No questions, Okay, let me erase this. I'll go for the other way now. I give you electric field strength. You plot me the potential graph. Okay. So let me this. Okay, I give you electric field strength first. Electric field strength is okay. Am I supposed to do? Okay, it's a straight line like this. So how's your electric potential graph looks like?
Curve.
It's a curve. It's a curve. So you have 4 type of curve: going up, going down like this, or going down like this. So which one? 1, 2, 3, 4. So how do you do that? So you see, so here also you can treat like that lah. You can treat like that. You can take potential as velocity, and potential as velocity, and E as the acceleration. So A is dv dt. You can imagine that. But what you do first, the E you must change to acceleration graph first, analog lah. So you have to reflect this graph first to negative. So the graph going to be like this. This is like your acceleration graph, going down. Okay, going down. Let me choose maybe this color. Okay, so this is your acceleration graph A. Okay, now this graph can you convert to velocity graph like this? So this is the acceleration getting more negative, getting more negative. So the potential graph must be what?
3.
So it's going to be a straight line or a curve?
Curve.
Oh, 3. Yeah, so you go for 3. Is it go for 3? Is it 3? The A get more negative. That means in the potential graph, the gradient must get more negative. Should get more negative. So which one? Which graph? Which curve getting more negative? Sliding or climbing? Sliding, right?
Yeah.
So it should be 3 or 4. 3 is highly negative, become 0. 4 is 0 become highly negative, right? So it should be what graph? Should be a 4.
Be number 4.
Like this 4, right? So yeah, should be like this. Highly negative. Yeah. So for example, you check again. The electric field strength is negative of the potential gradient. That's a relation. If I ask potential at this point, the gradient is getting greater, negative, but negative of the potential gradient. The gradient is negative. The gradient itself is negative. Negative, negative, negative become positive. So you get this graph. E. So it should be curve 4. Everyone agree?
Yep.
Yeah. Okay. Okay. So now let's go to the real business. Okay. Okay. This is asked in past year. Okay. Electric field strength equals to negative of the potential gradient relating to the graph. They said 1 year there is a positive charge of okay, I put positive 5 coulomb here, and for a distance of maybe r, there is another charge of negative 2 coulomb here. Okay, the party asked us to sketch a graph for potential versus r. For a potential versus r between the r. Okay, start from here. From here as 0 lah. Yeah, start from here. Okay. Okay, so start from here. Okay, let's see here. This part is here. This part is here. Okay, this is the the radius of the sphere lah. The radius of the sphere. This is the r. Small r. R1. Okay. Okay. So this is R2, radius of R2. Okay, so I put here like R2 here, R2 here. Okay, they asked to draw the potential versus R graph. Okay, So no need to draw inside. I want to draw in between here. Potential here is, I think it's around 4 marks question. 4 marks, actual exam, 4 marks question. Sketch the graph. Okay. How are you going to draw that? At the beginning here, the potential, because potential at every point here is caused by potential of the positive charge and the negative charge add up, right? What is the total potential? The V caused by the positive plus the V caused by the negative charge, right? At that point. So tell me, the one close here at this point, and at the point here, number 1 here, the two potential add up. The potential going to be positive or negative? Positive or negative? The potential here, R1. It's going to be positive or negative? What is the potential formula? Anyone? What is the potential formula? KQ over R, right? KQ, capital Q, capital KQ over R. This Q is the center charge, right? Center charge. When you calculate electric potential, do you need to include the sign of the charge? Anyone? The sign of the charge need to be?
Yes.
So at one, V positive greater or V negative going to be greater in terms of magnitude? In terms of magnitude. Positive will be greater or negative will be greater? Okay. V positive means the potential caused by this positive charge, positive 5 column. What is the potential caused by positive 5 column at this point? One is here, somewhere here. KQ or R. KQ or R. Okay, so let me expand this. The V positive is K, Q is positive 5, R will be the R1, R1, the small one, plus the V negative. The potential caused by V negative is K, Q is which Q? Negative 2 column divided by which R? Which R? The R from this point to here, this R, the R2. So tell me, the V total at this going to be positive or negative? K positive 5 over R1 plus K negative 2 over R2. Finally, you're going to give a positive answer or a negative answer? Mathematically, check. R1 is very small, so it'll give a positive answer. That means how the graph going to start with? Anyone? The graph going to be start with positive or negative region? We'll start with the positive here.
Okay.
The graph. Or start here positive. Okay, tell me, throughout this point, is there any point the V total, can it be 0? Can throughout any point here, can V total become 0? Is there any chance?
No.
Okay, what I mean is it V plus minus V negative? Can it lead to 0? That means V plus is same as V negative. Can happen in between or not? In between them?
I don't think so.
Why? You see, V total is what? V plus plus V minus. So V plus is K positive 5 over R1 plus K negative 2 over R2. Okay. At this moment, at the 1, R1 is very small. R2 is very big. Therefore, this V plus is bigger. But when go further here, what happened to the R1 value? Let's say you choose some point here, point B, let's say here, quite further away from positive. What will happen to the R1 value? The R1 will get bigger, right? Because further what? Further what? R1 value get bigger. What happened to the R2 value? R2 value from here to here, what? The R2 value, this is R2 now. R2 value become smaller, right? Can these two magnitude got chance to become cancel each other or not? Up is positive 5, negative 2 never change, but the R1, R2 is changing, right? R1 is getting bigger, so therefore the first value gets smaller. R2 gets smaller, so therefore V negative get bigger. So the first value getting smaller, the second value getting bigger. So there will be a point where both are like equal, become V total become 0, right? Okay. So the graph somewhere, the potential will become 0. Okay, you must realize there will be 0. V total becomes 0 somewhere at the center, not at the center, somewhere in between them. At that point, is it close to negative or is it close to positive?
Close to negative.
Close to negative. Very good. So the 0 happens close to negative. Okay, the close to negative. Okay, negative. Why? Because the charge of negative is small, 2. Charge of positive is big. So the cancellation will happen at close to negative. Like same thing for planetary system lah. The Earth and the Moon, same story. Earth and the Moon. Same thing. Like where the gravitational force will become nullified, become 0. Close to Earth or close to the Moon. Of course, quite close to the Moon, the gravity like balance, right? Same thing, because it plays the same rule as divide by R. So here, because the charge is very small, the cancellation happen close to the smaller charge. Okay, so the graph will go curve like this, going down. Okay, like this. Okay, then it will be a curve. It can't be a straight line because it's 1 over R. Then after that, what happened? After the V total becomes 0, you get closer further, point C. Let's say I put a point C here. What happened to the total potential? Positive or negative? Point C. Point C means very close to negative already. If very close to negative, the potential of negative get bigger than the positive. So the potential start to become negative. So become negative. So the graph will be like this. Okay, the graph will be like this. So this graph given 4 marks. 1 mark for the shape. 1 mark you got negative. 1 mark given for the 0 happens close to R2. Close to the negative. And 1 mark given the height, which have a greater height. This one will be have a greater height. The V total here greater or the V total here greater? The first one greater or the second one greater? First one will be greater V total because close to positive 5 charge. Okay, this is like a 4 marks question. Okay, so conclusion is, if you have a positive charge and negative charge, they're asking how the potential varies between them, between the R. The graph, you must recall, graph like this. Okay, from positive become 0 somewhere and become negative for potential. There'll be a point where potential cancels. Okay, so very important graph. Okay, now let me erase this everything. Okay, now more questions. Okay, so conclusion is positive, negative. If you plot what? V versus R, it's going to be like this. If the positive charge is positive 5 and negative 2, then this should be higher. Higher. And this would be lower. Lower. Okay, now second question. For this same system, R, how's the graph looks like? If you plot E versus R, electric field strength versus R, you move from positive charge. From positive charge, you move away from here as R. How's the electric field strength looks like? Electric field strength means like the total electric field strength. The total electric field strength. Total electric field strength. The electric field strength of positive 5 added by electric field strength of negative 2 at that point is the total electric field strength. Tell me how this graph going to looks like. It's like a 2 marks question. So at the beginning, we start here. At the beginning, I start with R1. Okay, R1. Sorry, this is R1. R1 means the radius of the first sphere, let's say, is R1. Okay, and the radius of the second sphere is R2. So I put the R2 here. R2. Okay, I want to start from here. So the electric field at close to R1 will be positive or negative? Anyone? Positive or negative at this point? Point A. I choose this the point A. At point A, the total electric field strength will be positive or negative. Because E total at one particular point is the total electric field strength caused by the positive and negative. What is electric field strength formula? Anyone? K Q over R squared, right? Electric field strength. Okay. So KQ R squared of the first one plus KQ over R squared of the second one, sorry, R squared for the second one, add up, you will finally get positive or negative for the A. Positive 5 bigger or negative 2 bigger? Positive 5 bigger, right? So at the beginning, the electric field strength will be positive. It's positive. Positive means we assume the direction is to the right. Okay. When you go further, point A, point B, and close here, point C, tell me, is there any point in between them? Can the electric field become zero?
Yes.
Can electric field become zero? One is positive, one is negative. Can any point in between, can the electric field, the total electric field, can it be zero? You see, positive, how the field line looks like? Outward, right? Outward, right? So at this point, the field caused by E1 is which direction at this point? To the right or to the left? To the right, correct? This is the field direction caused by the E1 because positive, the field is outward, correct? Okay, tell me, the field caused by E2, the E2, E2 is negative. The field line is inward or outward? The field line is inward, right? Okay. So at this point, the field caused by negative is which direction? To the right or to the left? It's to the right also, right? The electric field caused by the negative. Negative, the field is to the left, to the right. The field caused by positive at this point, the point A, also to the right. So both field are same direction, always to the right, both of them to the right. Can cancellation happen in between?
No.
Can't happen, right? Can't happen. So can E total achieve zero in between or not?
No.
Can't achieve. E total won't achieve zero. Okay, because E total is actually what? E total is KQ R1 squared plus KQ over R2 squared. Okay, so when R1 get bigger and R2 get smaller because you are moving from left to right, R1 get bigger. R1 is the R1, the distance from the left line. R2 is distance from the right. So R1 get greater R2. There will be a point where both are added, both become both are positive because same direction. When you calculate electric field strength, don't include the sign of charge. Just put the magnitude. So both positive, same direction. So the value won't get zero. The value will get minimum. It will get minimum. Somewhere it get minimum lah. If you do differentiation, the electric field strength get minimum somewhere in between. Okay. Then after that, what will happen to the electric field strength again? It will increases. Okay, it will increase. So this is the graph going to be for E versus R, a curve with a minimum value, okay, a minimum value which will happen close to -2 actually, -2. The minimum value normally happens to the weaker charge, -2, but never get zero. Okay, so please remember these two graphs, 1 and 2. For potential versus R, is a curve like this. It could be a 4 marks question. Okay, it could be a 4 marks question. Check with the pattern. Check it must be -0 somewhere. The first position must be very high. The next part, the negative must be low. If positive is higher than negative. If positive is lower than negative, then what change will happen? The first position high must be a little lower, and here must be higher. So check the chart. But anyway, potential versus R must be a curve and has a zero value at the in between. Okay, and this zero value achieve close to a smaller charge. Okay, and electric field strength versus R, will get a minimum. Okay, now how the graph going to looks like if both charge is positive? how the V versus R and E versus R graph looks like if both are positive. Which value will get 0 in between? The potential got chance to become 0 in between, or electric field strength got chance to become 0 in between? Anyone? Electric potential V total is what? V1, the first one and second one. V1 plus V2. Okay. So V total at the center, is there got chance to become negative or not? What is V formula you think about? KQ over R. Do you need to include the sign of the charge? Electric potential, the sign of the charge you need to include potential, because both are positive. So V1 going to be positive, V2 going to be positive. So V total going to be always positive. Can V total can be 0 in between or not? It can't. So the graph going to be a curve like this. Okay. And for electric field strength, the graph going to be like this. It's just exchange. Positive, positive. Electric field strength got chance to become 0 in between. Correct, right? You see the at this point, one electric field strength caused by E1, which direction? To the right or to the left? Electric field and E1 is going outward, right? The field is to the right or to the left at this point, point A. E1 will be to the left, to the right? E2, the second one, second body. At this point, the E2 will be which direction? Because it is also positive, the field is outward. So the field E2 also this way, right? E2. So the E1, E2 opposite direction, opposite direction. So there will be at one point, the E2 and E1 got chance to become 0. Therefore, E versus R graph, there will be a E total, there will be a chance to become 0 at one point. So it a curve and cuts the R graph, R axis and go down. So these are the two graphs you have to remember. If positive charge, E becomes 0 and in between. So it's a curve and going down. Potential will be a minimum value. Okay. For positive and negative, the V graph going to be what? The V graph going to be this graph. It's going to be like this. Okay. And the E graph will be with a minimum value. This graph will be exchange. Any questions so far? Can understand? Okay, so I hope this is the difficult part of electric field strength. Okay, the graph section. Okay, so now the graph I plot here, the graph only just at the surface of the sphere, I never go into the sphere yet. Okay, the graph into the sphere is empty still. I never draw yet. Now I'm going to show how the potential and electric field strength inside the sphere. Okay, if you have a sphere, so a sphere, if the sphere is charged, the charge always accumulated at the surface. The charge only accumulated at the surface. It can't stay inside. If it's a conductor, it's a conductor. If it's a conductor sphere, the charge only come to the surface. Okay. Okay. So from here to here, I'm drawing electric field strength. From this surface here, let's say this is a positive charge. So the field line, of course, E equals to what? KQ over R squared. So the graph going to be like this, going down. How the potential graph looks like? Potential graph for this sphere. Again, this is this R1, R1. So this R1, R1. Here I put the same R1. How the potential graph looks like for this sphere? What formula you must think about? KQ over R. So it also going to be a curve going down, Okay, but this is going to be more closer because R squared. Okay, now inside the sphere, the potential is constant. Okay, inside the sphere, what is potential? Potential at surface is the maximum. What is potential means? Electric potential. Can anyone recall what is electric potential means? What is electric potential means? work done to bring a unit positive test charge from infinity to that point, right? Okay, to that point. So when you want to get into the sphere, there is no need to do any work. The work is maximum already. Going into the work is constant. The potential is constant inside the sphere. Okay, so the V is maximum only at the surface. Okay, now tell me how electric field strength graph looks like inside the sphere. Inside the sphere, E equals to negative of the potential gradient. Inside the sphere, V is constant. So electric field strength inside the sphere will be like what?
A straight line going.
It's a straight line with
No.
zero. Will be zero. Zero. When potential is constant, the potential is constant. When the potential is constant, electric field strength become zero because electric field strength is negative of the potential gradient. You know, if potential is constant means potential gradient is zero already. Zero already. Flat line, but so is zero. So these are the two graphs you have to remember for positive charge. Inside the sphere, remember, put in your mind, inside the sphere, the electric field is always zero. Remember again, for a sphere, positive charge at the surface, inside the electric field is always zero. Okay. Only at the surface, the electric field is the maximum again and decreases. Okay. Inside the sphere, the potential is maximum and is constant also. It's constant. The potential inside is constant. When it comes to the surface, it start to reduce. So please remember these two graphs. Okay. So why I'm telling you this? Just now, positive and negative. I told you to draw the V versus R, positive, negative. The graph was like this, right? Like this, right? Okay. This is up to R1 only. R1 means the radius of the positive, R1 only. How the graph inside should look like? Should be a flat line. Okay. Should be a flat line. The potential is constant inside the sphere. Okay. And let's say this radius, let's say R2. So you draw here R2 here. R2 means the distance from here to here, R2. How the potential here will be also will be zero. Inside is zero. Okay, sorry, constant. The potential must be constant. Must be constant. Okay. If you plot for electric field strength versus R, the graph I say going to be like this. Like what? It's going to be like this. Going to be like this as a minimum value. At R1 of the electric field strength should be. This is this yeah. This is a combination of both. So you might have a value Yeah. Sorry. It should be negative zero. So only cos. So it could be negative zero. Both should be zero. Cancelling. Okay. So inside the sphere, remember inside the sphere, E is always zero and V is always constant. Okay. It's always constant. Okay. For a sphere. Okay. So look at this graph. Okay. This is the graph I'm mentioning. So for a positive sphere, the surface will be positive and reduces, but inside the electric field strength is zero. Okay. At the potential, inside is constant and reduces. Okay. Electric field E and potential V at point inside and outside are positively charged spherical conductor. It looks like this. Okay. Normally they'll ask you to draw the first half. Okay. So yeah, before we go to that, one question. Use the idea what you learned today. Can you please answer the question 6? Question 6. I give you 1 minute. Explain whether it is possible for the electric field to be zero at a point where the electric potential is not zero. Possible or not possible? Okay, what relation must come to your mind? Electric field is what? Negative of the potential gradient. This is what you have to think. Okay, you can imagine electric field as what? Acceleration. You can imagine potential as what? As velocity. If you want to, you are not really understand the what you call the relation. You can analog electric field like acceleration and potential like velocity. Okay, explain whether is it possible electric field to be zero, electric field replaced with acceleration. Is it possible the acceleration to be zero at the point where the electric potential can replace with velocity like analog one? Is it possible for acceleration to be zero at a point where velocity is not zero? Possible or not? Where the velocity is not zero. Possible or not possible? Explain whether is it possible for acceleration to be zero where the velocity is not zero. Possible, right? Okay.
Yeah.
If the velocity move with a constant speed, yeah, the acceleration could be zero. So same thing for electric field. So the answer is yes, can. Why? What is the reason you must tell? Because electric field strength is negative of the potential gradient. You must tell this 1 point. Yes, 1 mark. This is the second point. Because electric field strength is negative of the potential gradient. If potential is zero, doesn't mean the gradient is zero. Gradient can have a value. I can't draw this. Sorry, I couldn't draw. Should not draw this. The velocity is what? The point where the velocity not zero. Velocity is not zero. Yeah, correct. Constant like can. Sorry. So this graph applicable. V is constant. So electric field strength can have a value if the potential is constant. If potential constant, not zero, but it's constant, the electric field could be zero could be zero. So yes, the answer is yes. So E is the answer. So okay, so this is the last part of the topic. Okay, last part of the topic. Okay, so we're done with this electric field. Okay, so now let's go one path here relating to the entire thing. Okay, this question, Juno 5. Okay, look at question Juno 5, question 5. So read the question. An isolated conducting sphere of radius r is given charge positive Q. This charge may be assumed to act as a point situated at the center of the sphere. Okay. Show the variation with distance x, the center of the sphere, potential and charge is like this. Okay. Okay. State the relation between electric field and potential. What's answer? So
electric field is negative.
Yeah, electric field is negative of the potential gradient. You can put it in words. Okay. So next, so draw the electric field strength graph, positive Q. So you draw a dotted line. So here is going to be follow what? E equals to what formula? KQ over R squared. So it's going to be a Curve lah. It's going to be a curve. Okay, it's going to be a curve. R. Okay, class, sometimes you have to be careful. Let's say scale provided. Let's say this is E means okay, the top is E means 2R, it should get reached how much? How many E? E over 4.
4.
Because 2R squared, 4. Then 3R should reach how much? Should reach how much? E over 9. In exam, they will check that. How much it drops. 2R is drop a lot. Then 3R drop a little and 4 even little. So be careful with that. Okay. So yeah, it's a curve. Inside the sphere, it must be 0. The electric field strength must be 0. So this is the graph. Okay. Okay. Question June 6, question 5. Everyone give a try. Okay, A1, I think not a big problem. You know that, right? In AS itself, right? So electric field strength is what? Is a force per unit positive test charge. Positive test charge. Force per unit positive test charge. Don't mix the word positive. Okay. 2. Okay, state a formula for the electric field strength at the surface of a sphere. So what is the formula for electric field strength at the surface of the sphere? So E equals to K Q over, sorry, you can't write K, sorry. You have to write 1 over 4 pi epsilon naught Q, yeah, R squared. This the formula must come to your mind. So explain all the symbols. Explain. So Q is the charge possessed by the sphere, and R is the distance from the center of the sphere to the point where the electric field strength to be calculated. Epsilon naught, we call it as what? Permittivity of free space. Okay, permittivity of free space. You get the 2 mark off. Okay. Okay. Next, so we move on. B. 1 minute for you. Give answer. Okay, what formula are you supposed to use? You see there is a like a Venn diagram, a sphere, a Venn diagram. The voltage, the charge accumulating on the sphere is rises. Okay, we accumulate more charge when the belt rubs the, so it will be electrostatically charged. More charge accumulated means the voltage at the sphere will rises. Okay, what formula to be used? What is electric potential at the sphere formula? K Q over R must come. You must remember this for this part. Okay, K Q over R. Okay, so the question asking when the electrical breakdown happens, the maximum electric field strength is this. This electric field strength. This electric potential. You can't use this. Electric field strength. What is the formula? Electric field strength KQ over R squared to be used. Yes. So the E you substitute as 2 times 10 to the power 6. Charge. Yeah, you are looking for the charge, and R is the radius of the sphere. So you get the charge Q. You will get the magnitude of the charge in terms of column. Okay. So K, you must write 1 over 4 pi epsilon naught. You can calculate. Okay.
So I don't want you to do the entire working. I just want you to understand how do you go about this question. So when you read this question, you must understand E equals to KQ R squared to be used. They're looking for the charge at the sphere. So R is the radius of the sphere and the E is the electrical strength. Okay, so you get the magnitude of the charge. Okay, any question from here? Okay, let's move on. We assume we got the charge. Okay, I just want the technique only. How are you going to get the answer? So let's move to the next part. Okay. Okay, the next part. 2. So what is the potential at that sphere? So what formula must be used? Anyone?
KQ over R.
KQ over R to be used. And R we know is 0.35. And K, whatever charge you got here, you have to substitute here. So you get the answer. Voltage. Okay, voltage. We don't know what. Normally, if they never tell what is the nature of the charge, we assume it's positive. So we take it as positive. Okay. But remember, when you find electric potential, the sign of the charge must be included. Okay. If it's negative, include the Q as negative. But in this case, benefit of doubt, they never tell is what nature of the charge, so we take it as positive. Okay, so far straightforward. Yeah, this is the questions, the first question. Okay. Okay, so yeah, this one. Okay, question 3. Now this is tricky. Okay, 1 minute for you. Question 3. 207, question 3. So two charge point A and B are separated by a distance of 6 centimeter. A and B, two charges. Okay, they never tell what type of charge is that. Okay. Okay, so let me slow down. Okay, they say the variation of distance A to B, the electric field varies like this. Okay, varies like this. Okay. So very like it has a minimum value. Electric field strength. Okay, good. So now the question is, okay, come on everyone, give a try. An electron is emitted with negligible speed from A and travel along B, AB. Emitted speed from A and traveling towards B, A to B. State the relation between electric field strength and electric potential. This is straightforward. So what is the answer? Electric field strength is negative of the potential gradient. Okay. So move down. Okay, now. The area below the line of the graph represents the potential difference between A and B. Determine the potential difference between A and B. Okay. So this is tricky, but they already help you here. They say the area below the line of the graph is potential difference between A and B. Determine the potential difference between A and B. So what do you do? You go back to the graph. From A to B, you find this area, the area under the graph. It's a curve border, so you have to count the boxes to find the potential difference. Let's say you got 10 volt, the area under the graph, you got 10, then the difference is 10 volt. But make sure the kilovolt has been changed to volt. Make sure the centimeter changed to meter, so that you get in volt. Okay. Okay, now next, C. So assume that potential you already know. You know the potential already. Use your answer in B to calculate the speed of the electron as it reaches point B. This is tricky. Okay. Use your answer in B to calculate the speed of the electron as it reaches the point B. Okay. Of course, Cambridge
If you clueless, the clue is on top. Okay. So they're asking what is the speed reaches at point B? Okay. The potential difference, you know, A to B, you know, the potential difference. Okay. And I scroll up. Okay. So you know what else? You know the potential difference. You know this graph. This is the only two stuff you know. They're asking what? Yeah. Use your answer in B. What is the speed attained by the electron reaches the point B? What formula come to your mind? Anyone? The gain in kinetic energy is equals to what? Anyone? You know the potential difference. So you have two body as charge, and electron is moving from one potential V1 to another potential V2, and we know the changes in potential. I got a changes in potential. So when the electron move from here to here, they're asking what is the gain in kinetic energy. So gain in kinetic energy equals to what? Work done, right? Work done. So gain in kinetic energy same as what? Anyone? Q changes in V. Q changes in V. Okay, gain in kinetic energy is Q changes in V. So this formula must come to your mind. The changes of V is here, got from here, and Q. Which charge do you use? Charge of the electron. Charge of the electron 1.6 times 10 power negative 19 coulomb you use. Changes of V got, you put here, you get the calculate the speed of the electron. So you get the gain in kinetic energy. So you get this in terms of joule, but because they want the speed, so what you need to do extra, right? The gain in kinetic energy, you put half mv squared. It's actually gain, you know. So gain means half mv squared minus half mu squared. But u 0 because it's from rest. So only half mv squared survive. So you can find the V. You can find the V. Mass of the electron, you can get it from the front page, right? In the exam, 9.1 times 10 power negative 31 kilogram. Yeah, you can work out the V. Okay. But this is the flow. So those who think about the first point, gain in kinetic is the work done by the field. Q changes of V comes to your mind. Then you are on a correct track. Q changes of V. Get one mark. And half mv squared equals to that. You can find the V. Any questions from here, this part? Any part you don't understand? Okay. So remember, if the question asking for kinetic energy, potential energy, all linked to work, which is Q changes of V. Q changes of V. Q changes of V. Okay. So we assume we got the speed. Okay, we go down. D. Okay, D. Determine the value of D at which the electron has maximum acceleration. Okay. For this, I have to go back to the graph. So let me go back to the graph. Try to understand the question first. For the question one, what D the electron attain maximum acceleration? Okay, so I go back. Okay, so I go back to the graph. Okay. Okay, anyone? At which D the electron has the maximum acceleration? How are you going to find the D which gives you the maximum acceleration? Which D? The A is maximum. At the point A, at the point B, at the point C. Anyone? Oh, I put another one, D. Okay. So A, B, C, D. Okay. At which point, at which D, the A is maximum?
How you can find acceleration from this graph? This graph is what versus what? This graph is electric field strength versus D. Electric field strength, you know. Electric field strength, okay, maybe tell me, anyone? If A is maximum means how A related to electric field strength? How do you link acceleration to electric field strength? Electric field strength is, can you write electric field strength in terms of force? Then you got the answer already. Because acceleration is linked to force, right? If A maximum means the net force must be maximum, right? If S is the force experienced by the charged particle must be maximum to attain a maximum acceleration. To have a maximum force, how E and F related? Anyone? How E and F related? E equals to F over test charge, right? Q. So force equals to Q times E, your AS knowledge now, right? So the A become max when F is max, F become max when the electric field strength become max, greatest. So which point electric field strength is the greatest? The A. So the A is the answer. At A, the electron attain maximum acceleration. Okay. If they ask for the reason, what is the reason? You say to attain maximum acceleration, force must be maximum. To have force maximum, F equals to QE, E must be maximum. Therefore A. Okay. Okay, now any questions from here? I hope you understand. A particle attain maximum acceleration. Okay, tell me at B, what happened? What happened to the acceleration of the electron at B, at the point here? Is it still accelerating or acceleration is 0? Anyone? At B, at the point, lowest point, the particle still accelerating or the acceleration 0? Is it acceleration 0 at B? True or false? At B, do you have electric field? You still have electric field. You still have electric field, because you still have electric field, but the electric field is minimum lah. Because you still have electric field, therefore you still have force. Because the particles still have force, therefore it do accelerate. So at A at B is not 0. The A at B is a minimum value, minimum acceleration. Minimum acceleration. Yes. Okay, now guys, please tell me at acceleration at A and acceleration at C, what's the difference? Acceleration at A and acceleration at C, what's the difference? Anyone? The electron experience acceleration at A, the electron experience acceleration at C. What's the difference? The magnitude wise, A has a greater magnitude than C. Then direction, is it same or different? The direction is same or different direction? The electric field. Anyone? A and B, is the electron accelerating the same direction or the different direction at C? Same direction, right? Still the same direction. Why? Anyone? Why? Because the electric field is always positive. It's always positive. So electric field is always positive. That means the electric field is always directed to one side, only one side. Therefore, the electron keep on accelerating to one direction. If the electric field strength become negative, if the graph is getting to negative, down here negative, then we see it accelerate in opposite direction. Okay, so go back to the question. So determine the value of D with the electron as a maximum acceleration. The D must be the point A, should be the point A, this position, 0.
0 centimeter is your acceleration is maximum. Okay. Okay, 2 marks. Without any further calculation, describe the variation with distance d of the acceleration of the electron. How the acceleration varies. Okay, how the acceleration varies from A to C, how the acceleration varies. 2 marks. At A, acceleration is maximum, okay, because electric field strength is maximum, but you must give a statement first. The electric field strength is directly proportional to the force. Therefore, acceleration is maximum at the beginning. Acceleration decreases to a minimum value at that particular d, 4 centimeter, and the acceleration increases again after passes the 4 centimeter because electric field strength increases. Okay, so electric field strength is directly proportional to the force. So therefore, bigger electric field strength means bigger acceleration. Okay, so maximum at the beginning reduces at 4 centimeter and increases again at 6 centimeter. Okay, so that should be the answer at the last point. Okay. Okay, class. So that's a lot about this topic. Okay. I want you to do the past year. You can't do much because it's including 2 topics, capacitance. You give a try the questions at the back here. Okay. You see the note file at the back got tutorial questions. Give a try and do these questions at the back. You get questions, try to do, and a solution also provided. You go through the question with the answer, then go to the past year. Okay. So yeah, any questions?
No.
Okay, class. Your face-to-face classes. I think today we had a meeting. I think the face-to-face classes for you, they are setting the SOP. I think they are how to do that. I think they suggested that every intake only will have face-to-face class for 2 days in a week. I think. I don't know how they're going to do that lah. So 2 days you will have face-to-face class, come to the college. Another 3 days I think is going to be like online. Other intake will come to another 2 days. This is the arrangement they are trying to make.
Okay.
Okay, so I stop here. So I see you on Monday according to the college timetable. Okay.
Okay.
Bye.
Okay. Thank you.
Okay.
Bye.